Hi everybody. Today we're going to do the last lesson of functions, and that is interpreting graphs. This is probably the most fun lesson because you can really get creative in how you're in looking at some of these graphs and what they possibly could represent. So hopefully you enjoy this lesson. So let's get right into it. So here we go. The Carter family are driving to Yukon for a family vacation. Okay, the graph represents the amount of fuel in liters in the gas tank of their car on the first day of their journey. Okay, so this is kind of important. Let's first of all look at what our variables are. Well, we have time of the day. That's 12 p.m. That is 5 p.m. Okay, 5 p.m. That's 7 in the morning. So, and then okay, so it looks like this is a whole day. They might have left in the morning and drove until about 5 p.m. Okay, and then here's the liters. So this is their gas tank goes all the way up to 60 liters. All right, let's look at some of these questions. All right, the graph of the journey is divided into 8 line segments. Okay, write a reference to the journey. Explain what is happening between A and B. Well, A and B, they leave. Okay, I'm not going to write this down, so we can just you can just listen to me here. So from A to B, well, I'm going to go ahead and pause this and see maybe you can actually go ahead and interpret all of these. Then I'll come back with some of my explanations. Okay. All right. So here's my take on this. All right. Well, from A to B, it's clearly that they leave in the morning. They leave at 7 in the morning and they drive until about 7, 8, 9, 10 p.m. or 10 a.m. here. That's B, and they're losing fuel here slowly but surely, and so they're clearly driving on their journey. All right, they could be singing in the car and definitely playing some fun games. Okay, and then from B to C, well, from B to C, they're not losing any fuel, but time is still ticking. So that looks like about half an hour there, 10:30. So from B to so for half an hour, they look like they stop. They stop somewhere, but when they leave again, it looks like their fuel is way up here, so they must have stopped at a gas station from B to C. Okay, and then from C to D, well, from C to D, basically that's the same time. That's 10:30, so that's just that was just the car got some more fuel. They must have refueled all the way back to 60 liters. Okay, what is the rate of fuel consumption in liters per hour between D and E? All right, this is kind of now we're finally getting to some usefulness of all these functions here. So the rate of fuel consumption from D to E. Here's D to E. Okay, well, in order to find the fuel consumptions, I need to know how much fuel they used over what time period. Well, let's see the fuel consumption. Fuel consumption is calculated in liters per hour. Okay, so how many liters did they use up? They went from 60 all the way to about 25 here. So 60 minus 25 equals 35 liters. So they used 35 liters. And how much time went by? So they went from 10:30 all the way to 2 p.m. So if I was to calculate those hours there, I would have to, well, let's put this into 1400 hours. Yeah, I'm going to change this to 1400 hours in order for this to make sense. So let me see the time. So that was 1400 minus 10:30 there. So I can just, I can do that in my head. That's 3 hours, 3.5 hours. Okay, so 3 hours and 30 minutes there. So if I go down here, I can write that as 3.5 hours. So if I wanted to get that per hour, which is what they want, I need to divide both top and bottom by 3.5. So 35 divided by 3.5 is obviously 10 liters per 1 hour. Okay, so that's not bad. Every hour they lose about 10 liters. Okay, which line segment represents the car being refueled for the second time? Okay, well, that's over here because they're not moving, and the car, clearly it's got refuel there. Okay, now this is actually slightly sloped. This looks like a vertical line, but really it's more like a really steep line like this, because time is ticking while you're refueling. It might only be like 2 minutes, but nonetheless, time is slightly ticking while you're refueling there. Okay. I don't know if you can see that. That's supposed to be this sort of thing here, like that. If you can see the slope, but it's so little time has gone by that it's really hard to see the slope on that line. So that would be G to H. GH there. Calculate the total time when the car is being driven. Okay, let's look at that. So the total time, well, we got 7 to 10, that's 3 hours, and then we said when another 3, so that's 6.5 hours, and then we got an hour here, so 7.5 hours, and then we have about another hour here, so 8.5 hours. So 8.5 hours in the car, 8.5 hours, or 8 hours and 30 minutes. 8 hours and 30 minutes. Okay, so if fuel costs 85 cents per liter, calculate the cost of fuel used for the first day of the journey. Okay, well, if it's 10 liters per hour, so I'm just going to multiply their thing by 8.5, because every hour they use up 10 liters. So they must have used up 850 liters. Wow, that's a lot of fuel. They must have been driving all day. So, and if it costs 85 cents, well, I'm just going to multiply that by 0.85, because I want it in dollars. And I'm going to get 850 times 0.85 on my calculator here. 700. Whoa, that's a lot of money. 722.5 dollars. Okay. Okay, I must have gone somewhere wrong. That's way too high for the money. I think, yeah, right here, I think it's not 850 liters. That's way too many liters. Okay, no car can fit that many liters. So it was 10 times 8.5 the hours, and that's only 85. Okay, so I'm just going to drop one of these zeros and make that into a $72.25. Okay, sorry about that. All right, now keeping going here. Let's look at some. These are kind of fun. Suggest a possible scenario for each of the following graphs. Ooh, okay. Well, here we go. We have to look at the variables. We have speed and time. So clearly, I'm going at this is some speed, whether that's 50 or 10 or whatever, it doesn't matter. I just know that's 0. So I can maybe say a car, keeping it with the same sort of as above here. So that's a car going at a constant speed. Then maybe it slows down a little bit and then drives. So that's deceleration. So that's constant speed here, and then deceleration, and then constant speed but not as fast, and then it speeds up, and then again it cruises, and then it slows down and comes to a stop, because that's down here is 0. So this could be you driving through a city, right? You're driving at a constant speed, you slow down a little bit, maybe there's traffic, then you keep driving at a slower speed, maybe the road opens up a little bit, you drive a little bit faster, you drive constant, and then maybe there's a red light and you sort of slow down to a red light. This one's a little bit more tougher, okay, because this one you really accelerate. If you're a car, you really accelerate, and then you decelerate, and then you stop, and then you accelerate again, okay, and then you decelerate. This could be if you're like doing like sprints. Maybe you don't, it doesn't have to be a car. You can be sprinting. So you start off sprint, and then you sort of slow down, and then you sprint again, sprint, and then you slow down, and you sprint, and you slow down. Okay, there's a lot of answers that can fit these graphs. Okay, sketch the graph here. Sketch a graph with no scale for each of the following. The oven temperature when baking a pie. Well, when baking a pie, you might want to, first of all, the temperature, well, it's not going to be 0. It's not going to be freezing in your oven, so it might be at room temperature. And then maybe you heat the oven up like this, okay? And then once you get to a certain temperature, you keep the oven at that temperature, maybe 375 for a good apple pie. right there, you're baking the pie, and that's pretty much it, right? Then you take the pie out over here, all right, and then you let the thing cool down a little bit, and it might look something like that. All right, Ben taking part in a 100-meter sprint. Okay, well, you accelerate. Usually, people's when you're running, your start is the slowest, so your speed will go from 0, and it might climb like this. Might not be a perfectly linear thing. It might be more like this. You might accelerate and then reach a constant speed, and then that's it basically. And then you come to a stop. Okay, so whether this is now getting really technical here, whether this is like this or straight, it's really hard to say. I think most people kind of pick up speed and then accelerate, and then they do a cruising speed. Okay, thanks for watching, guys, and this is our last lesson on functions. Hope you enjoyed it. See you in class.